Thermal expansion is a fundamental phenomenon in thermodynamics where materials increase in size when heated. Understanding this concept is crucial for engineering, construction, and everyday applications. Thermal expansion is the phenomenon where materials increase in size when their temperature rises. This happens in solids, liquids, and gases, though the amount of expansion varies significantly between different materials. At the molecular level, thermal expansion occurs because of changes in atomic vibration. In the cold state, atoms vibrate slowly with less kinetic energy and stay closer together. When heated, atoms vibrate faster and more vigorously, requiring more space between them. This increased spacing causes the entire material to expand. Thermal expansion occurs in three distinct forms. Linear expansion refers to expansion in one dimension, like the length of a metal rod. Area expansion, also called superficial expansion, occurs in two dimensions, such as a metal sheet expanding in length and width. Volumetric expansion happens in three dimensions, where an object expands in all directions, like a metal cube or a volume of liquid. The change in length due to thermal expansion is calculated using a simple formula. Delta L equals alpha times L0 times delta T here. Delta L is the change in length, alpha is the coefficient of linear expansion, which is a material property, L0 is the original length before heating, and delta T is the change in temperature. This formula allows us to predict how much a material will expand. For area expansion, the formula is delta A equals beta times A0 times delta T, where beta is the coefficient of area expansion. For volume expansion, the formula is delta V equals gamma times V0 times delta T, where gamma is the coefficient of volumetric expansion. Interestingly, beta is approximately equal to 2 times alpha, and gamma is approximately equal to 3 times alpha, showing the mathematical relationship between the different types of expansion. Different materials expand at different rates when heated. The coefficient of linear expansion, alpha, is measured in units of per degree Celsius times 10 to the power of -6. Steel has a coefficient of 11, aluminum has 23, copper has 17, and glass has 9. This means aluminum expands more than twice as much as steel for the same temperature increase, which is critical information for engineers selecting materials. Thermal expansion has numerous practical applications and considerations. Bridge joints include expansion gaps that prevent the structure from buckling during summer heat. Railway tracks have small gaps between rails to allow safe expansion and prevent warping. Running hot water over a tight jar lid causes the metal to expand, making it easier to open. Mercury or alcohol thermometers work by measuring the expansion of liquid as temperature changes, providing accurate temperature readings. Thermal expansion is a universal phenomenon that occurs in all materials, though the amount varies significantly depending on the material's properties. Engineers must account for thermal expansion in every design, from bridges and buildings to pipelines and electronic circuits. Ignoring thermal expansion can lead to structural failure, equipment damage, and safety hazards. Understanding this concept is essential for anyone working with materials and temperature variations.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.